Welcome back, students. In this video, we're going to cover the Module 9, study guide. So, Module 9, right triangles and trigonometry. Covered the Pythagorean theorem. That's a squared plus b squared equals c squared. Trigonometric ratios. We've got SOHCAHTOA over here to the side. That's sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. Complete the statements below. So we got opposite over hypotenuse, so that's sine. Adjacent over hypotenuse, that's cosine. Or we can just write COS. We'll just write COS. That's what's on the calculator. And then tangent equals opposite over adjacent. Okay, scooching up the page here. So special right triangles, 45, 45, 90 here on the left. As we talked about before, now this will be on this and this up here. So the SOHCAHTOA and your special right triangles, that's on your reference sheet, but it's still good to familiarize yourself with this. So let me just write in a couple of things. So 45, 45, 90. Over here we know that x represents that these two guys are congruent, or they're equal to each other, and that the hypotenuse is going to equal one of these sides times the square root of 2. And the square root of 2 is like 1.4. We're leaving it in radical form, then square root of 2 would be fine. You know, if this side was 5, this side would be 5 because they're the same, and this would be 5 times the square root of 2 because it's this side times the square root of 2. 30, 60, 90. So this leg is x, or the relationship between that and the hypotenuse. The hypotenuse is double this side. This is always where the 90 and the 60 are. It's going to be the shortest side. And then over here, this is going to be this side times square root of 3. And again, this is 2x, so if this side was 2, this side would be 2 times the square root of 3, and this side would be 2 times 2, which is 4. Hope that reminds you, jogs your memory a little there. All right, so let's just get right into it. Number 1, which of the following could be measures of the sides of a right triangle? So to determine the sides of a right triangle, we use the Pythagorean theorem. A squared plus b squared equals c squared. Let me bring my microphone a little closer. So we're just going to square these and see. I'll write out because only one of these 4 is correct. But so 3 square, the square root of 3 times the square root of 3 is 3. This is 4. This is 5. Well, 3 plus 4 is 7. 7 does not equal 5. So that's a no. All right, so we square these. So this is 5 plus 12, which is 17, which does not equal 13. All right, let's just use our calculator. All right, so this will also give me a chance to scoot you over here. So let's just square this plus this. You remember, the c is always the bigger side. So 9 squared plus 16 squared equals 337. So we're going to hit square root and see, is that 25? I'm pretty sure it's not, and of course it's not. So the answer is no to that. And again, I'll kind of go over the calculator a little more. So let's look at the last one. 7 squared plus 24 squared. See, I'm just typing in the number, hitting squared, equals. All right, and 625, what is the square root of that? It's 25. So this is our answer. So I want you guys to get in the habit of using that calculator, but we'll put it over here. So 7 squared plus 24 squared equals 25 squared. 25 squared is 625. 7 squared is 49. 24 squared was 576. Whoops, 576. When you add these two together, you get 625. So that's how that was our answer. Okay, scooch down, make some room here. Number 2. And I'm going to write this out, but I'm going to try to, because we're using Pythagorean theorem for a lot of this. So I'm trying to use both. I want you guys to get in the habit of using that calculator. Parents, if you're watching, and I hope maybe you are, please get them to use a calculator. So during a storm, tree breaks 4 feet above the ground. So if it breaks here, this is the ground, that's 4, okay? You guys are always scared of these word problems. And it falls to form a right angle. There you go. If the top of the tree rests 11 feet from the base, so top of the tree, base, 11 feet. Okay. Approximately how tall was the tree before the storm? So we're going to find this and then add it to that, because we have 4 feet here, and then this is the tree that fell over. So our answer is going to be x plus 4, but first we need to find x. A squared plus b squared equals c squared. Let me just do this, because I got you guys going so well on those the opposite and adjacent and all that, and you guys are scared of ABC. No big deal. It really doesn't matter which these two are, as long as the two short sides, the hypotenuse is the same. But here we go. So a squared, so 4 squared plus 11 squared is going to equal x squared. So 4 squared is 16. 11 squared is 121. It's going to equal x squared. Add those two together, that's going to be 137. X square root. So x equals. Now, let me just scooch here so you guys have that. So 4 squared, so that's 16, plus 11 squared, there's your 121, making sure y'all can see it. The lighting is kind of weird. Equals, so we got 137. Now we take the square root, and that's 11.7. Okay, everybody in agreement with that? Now, because we need to know how tall the tree was before the storm, it's x plus the 4 feet that's left. So x plus 4, or 11.7 plus 4, gives us 15.7. And we're going to round that, because it says approximately how tall. We're going to just round it up, and we're going to say 16 feet. Okay, let's flip over. All right, top of the second page. Fill in the blanks using the available answer choices. All right, so we know a squared plus b squared equals c squared. That's a right triangle. If you guys remember back to your Module 9 packet, we mentioned greater than gave us acute or obtuse, and then the other was the less than. So 15 squared is 25, so it's saying here if a squared plus b squared is greater than c squared. So if it's greater than, that makes the a and b sides longer than the c side. And then if a squared plus b squared is less, so if the c is bigger, so notice this is acute. I didn't draw very well, but this is obtuse, so I think I did that backwards, but when it's greater than, it's acute, because the A and B are bigger than C. It's smaller that way. And then if it's less than, it's obtuse. So the C is bigger, so that angle is bigger than 90. So acute, obtuse. All right, scooch down the page here. All right, use Pythagorean theorem to find the length of the hypotenuse in the figure below. Round to the nearest tenth. So we got 10 here, 30 here. Our hypotenuse is across there. So C. So a squared plus b squared equals c squared. A squared is, and it doesn't matter. So 30 squared plus 10 squared equals c squared. 30 squared is 900. 10 squared is 100. So c squared equals 1,000. Take the square root. C is going to be 31, I think it's 0.7. Let's do calculator here. So 30 squared plus 10 squared. 100, take the square root. 31.62 is 31.6. Okay. Let me get this in the... I'm just going to try to get both of these where we can see them. I can just do one after the other. All right, so number 5. Find the values of x and y. Now, you guys have heard me say it enough. We have to find x and we have to find y. Now, here, I'm going to confuse you guys. And I'm going to try not to, but it's going to happen. So, we have a 30, 60, 90 triangle. We saw on the other page. Now, don't let this x get confused with the x I'm about to put down here. In fact, we're gonna say this is. Hold on. We're gonna say it's C because this is the hypotenuse. Excuse me. So we're gonna call it C, because x is just gonna confuse us. Because the 60, 90 side over here. This value is x. Y over here, this side, that's the 90, 30 side, is x times the square root of 3. And C over here is the 2x. This is your special right triangle rules. That's why I want to just change that value. So this here, so y over here is x, which is square root of 15, times the square root of 3. All right, so y is going to equal the square root of 15 times the square root of 3. Again, because this side is x, this side is this times the square root of 3. X is square root of 3. That's why it's written that way. All right, so square root of 15 times the square root of 3 is the same as the square root of 45. Okay, hang with me. Okay, square root of 45 is, I'm going back to algebra, maybe even a little bit before that, but 45 is 9 times 5. Okay, still with me. All right, the square root of 9 is 3 times the square root of 5. All right, so here's our y. Now we got to find it's x, but we're saying c because I'm trying to not confuse you guys. All right, so c is 2 times x, or 2 times the square root of 15. Okay, so we have 2 times the square root of 15, and we have y equals 3 times the square root of 5. So our answer is A. Look, see, this is 3 times the square root of 5. That's not right. 2 times the square root of 15, but that's for the hypotenuse, not the y side over here. Hopefully changing that helps. All right, number 6. Diagonal of a square is 12 inches long. What is the length in inches of each side of the square? Write the answer in simplified radical form. All right, so I'm gonna draw this over here. So we got a square. You know, it has 4 90-degree angles. I'm just drawing 2 of them so I can put the diagonal that way. Okay, they tell us the diagonal is 12. So what we have here is a 45, 45, 90 triangle. So I'm going to draw it down here now. This side was 12. All right, so we know that 45, 45, 90, these two sides are congruent. This side is, the hypotenuse here is that times the square root of 2. Okay. All right, so to get x, we can do it a couple of different ways. And I'm going to just scooch here so I can show you the 2 different ways I would like to prove the answer here. So I do it this way. So this is worth x times the square root of 2, then x equals 12. Let's see, that's going to be, if we're dividing both sides by x, so we're basically going to have it 12 divided by the square root of 2, because if we're trying to, just to show you here, so these two would cancel out. Well, we need this number, so we would divide both sides by the square root of 2. I've lost what I'm trying to say, but so now to get rid of the square root on the bottom, we're going to multiply both sides by square root of 2. So you end up with, it's 12 times the square root of 2 divided by 2, because this times this is 2. And then 2 goes into itself one time, it goes into 12 6 times. So x equals 6 times the square root of 2. All right, so that's one way to get the answer. Now, here's the other way. So if, again, we have our 45, 45, 90. These are x. This is 12. So x times, hold on. So we got 12 squared. See, a squared plus b squared equals c squared. So c squared is 144 equals x squared plus x squared. That's this times this squared, and this squared equals this squared. You know, a squared plus b squared equals c squared. So now we have 2x squared equals 144. Divide both sides by 2. X squared is going to equal 72. We take the square root of both of these. So x equals the square root of 72. 72 is the same as 36 times 2. The square root of 36 is, you guessed it, 6. So 6 is square root of 2. So we got the same answer, just two different ways. So again, the answer up here is 6 times the square root of 2, because it wanted it in simplified radical form. Okay, so going to, what was that, number 6? Yeah, so going to number 7 up here at the top of page 3. Two radio towers have been positioned 8 miles apart, point A and point B. D is located exactly 4 miles from point A. The third tower will be placed at the point C up here, so that all 3 towers are equal distant from one another. So you really got two right triangles here. Just 1 second. So equidistant. Man, I didn't even do that problem. Hold on 1 second. Okay. All right, so if the towers are all equidistant, so that's going to make, see, and this is split in half. So they told us that these were 8 miles apart. So 4 and 4, this is 8. So it's going to be 8 here and 8 here. So this was an equilateral triangle. It makes it equal, yeah, so it's equal angular. So this whole angle, this is a 60, and this is a 60. So let me write this in different color. So if this is a 30, 60, 90, this is your x. This is your 2x, see we got 4 and 8, so we're in business, and then this side is x to the square root of 3, x times the square root of 3. So to get our third side here, we can just use our special right triangle, and so our answer here is going to be 4 times the square root of 3, and if we use the calculator, show you, it's 4 times 3 square root, that's the square root of 3, 1.73, equals, so we got 6.9. So the answer is 6.9 miles. Okay, scooching down. Sorry about that. Just double checking something. Okay, number 8. Jason's standing 100 feet from the base of the flagpole. He is looking up at the top of the flagpole at an angle of 30 degrees. So here's your 30. So makes that 60. So this is your x. This is your x times the square root of 3. And this is your 2x. So using the special right triangle. But we can also, use trigonometric ratios too. So I'll show you both here. So just keep that in the back of your mind. But we're going to do this. So we're looking from this angle. Over here, our flagpole, that's our opposite. And this would be, since it's touching our angle and it's not the hypotenuse, that is our adjacent. All right, so they want to know how tall the flagpole is. Now, he's looking from here. We're going to find this portion of the flagpole using trigonometry, but then we're going to have to add his height because we want to know the flag is going to be from here to here, and this is going to be x plus the 5.5 feet for Jason. So just want to make sure you guys see that. Okay, so we don't care about the hypotenuse here. We have an opposite and adjacent, so we're using tangent. Let's see. And we have a 30-degree angle, so our tan 30 is going to be equal to, so hold on, TOH. Tangent equals opposite over adjacent. So tan 30, our opposite is x over our adjacent, which is 100. We're going to multiply both sides by 100 to isolate x. So x is going to equal 100 times tan 30. Now, before I do this on the calculator, I'm going to write this under here. So the buttons to get this. So we're going to go 100 times, I know, don't let that x fool you. This is buttons on the calculator. Times, we have to put the angle measure in first, the 30 tan, and then you have to hit equals. So watch closely, and here's what we're doing. 100 times 30 tan equals 57.7. So, sorry, let me go back to this. So x equals 57.7. What is that? All right, so that was feet. Now, how tall is the flagpole? It's x plus 5.5. So 57.7 plus 5.5. That's 2, 3. So 63.2. And I thought it was multiple choice, but the answer is 63.2 feet. Okay, scooching down here. Try to put both of these in view best I can. All right, number 9. Which trigonometric ratios have a value of 4/5? Select all that apply. All right, we don't have a 4 and a 5, but if we divide all these by 3, 9 divided by 3 is 3, 15 divided by 3 is 5, and 12 divided by 3 is 4. So to get 4/5, be like that. So let me do this. So for B, this is the side that's touching it, but it's not the hypotenuse. So this is the adjacent. If B's on the right, over here is the opposite. And of course, this is the hypotenuse. All right, for angle A, this is the side touching, but not the hypotenuse. So this is the adjacent there. Over here, A's at the top, this is the bottom, this is the opposite. Of course, the hypotenuse is the same for both. So if we need 5 on the bottom, so this is the hypotenuse we need. And then it's going to be, the 4 is going to be the adjacent for B. So, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. We're not using tan because we're not using this side. So it's going to eliminate the opposite for B, and it's going to eliminate the adjacent for A, so no tangent. So for B, this is the adjacent over the hypotenuse. So for B, adjacent over hypotenuse, cosine for B. All right, and then for A, it's the opposite over hypotenuse. Opposite over hypotenuse, so it's sine for A. Hopefully that made sense. All right, number 10. What is the value of tangent for a 30-degree angle? All right, so we can do this. Well, you could use a calculator, and if you hit 30 tan, it's going to be 0.577. Well, that's not an option. But if we use our rules for special right triangle, so 30 is up here, 60 is down here. This is x times square root of 3, and this is 2x. So if our 30 is up here, the tangent is your opposite. So this is the top, this is the bottom, opposite over adjacent. Excuse me, so tangent, opposite over adjacent. So for 30, it's going to be x over x times the square root of 3. Okay, well these x's cancel out. So you have 1 over the square root of 3. 1 over the square root of 3. Okay? All right, flip it over. Page 4. Make sure, yeah, page 4, that's it. We've got 4 problems. So let's scooch back, got to make room. Number 11, very quickly. All right, what is the measure B to the nearest degree? So angle B, I mean. So angle B. So this is our adjacent. It's on the right, so our left is our opposite. We've got a hypotenuse there. We don't need that. So we have an opposite and an adjacent. So tangent is opposite over adjacent. So for measure of angle B, our inverse tangent is going to be opposite, which is 4 over adjacent. And I'm going to tell you how to type it in the calculator. You're going to type 4 divided by 7 equals, and then you're going to hit the second button and tangent. Okay, so measure angle B equals, so again, 4 divided by 7 equals second tangent, 29.7. And that's talking about an angle, so in degrees. All right, number 12. Fill in the blank with the available answer choices. The hypotenuse of a right triangle is 20 units, and one of the acute angles is 35. To the nearest tenth, what are the lengths of the legs? So let's draw a triangle. We'll draw it over here. So right triangle. The hypotenuse is 20. One of the acute angles is 35 degrees. What are the lengths of the other legs? So so one leg is going to be the opposite because this is the right, that's the left, and one's going to be the adjacent. All right, so we have a hypotenuse here. So we can use if we're looking for this, and we have this and this, we can say opposite over hypotenuse. Well, first let me just, so, TOA. So I'm going to use, I have an hypotenuse, so I'm not using tangent here. I'm going to use the cosine of 35, which is opposite over hypotenuse, to find this one, and then the sine to find this one. Bear with me. So sine 35, that's going to be opposite, I'm just going to say O over hypotenuse, which is 20. Multiply both sides by 20. So O equals 20 times sine 35, which, if calculator, is going to be 20 times 35 sine equals. Okay, so our opposite side equals Oops. So we got 20 times 35 sine equals. So 11.5. Okay, so 11.5. All right, let's do the other side. Just a second. Oh well, I'll just use this. So other side, it would be cosine 35 equals the adjacent, so we'll call it A, over the hypotenuse. So again, we're going to multiply both sides by 20. A is going to equal 20 times the cosine 35. And when we use the calculator, it's going to be 20 times 35 cosine equals. Cosine equals. So we got 16. Let's see, hold on. So our adjacent equals 16.4. And looky there, 16.4, 16.4. Oops, sorry, I was a little over there. Okay. All right, scooching up. Number 13. General Sherman is a tree that's located in the Sequoia National Park. It stands 275 feet tall. Let's see. So we'll just draw a little tree here. He's 275 feet tall. Okay. To see the top of the tree, Carlos looks up at an angle of elevation of 11 degrees. So here's Carlos. He's looking up at the tree, and this is gonna not quite be right, but from his eye, it's gonna be. You see, it's gonna be the tree. His eye level is lower here, so he's 6 feet tall. So we're gonna end up adding. We're gonna actually subtract six from the tree. I drew it wrong, but our triangle would actually be like be here. Anyway, the tree's 275. We subtract 6, so this other side of our angle is 269. 11 degrees down here, and they're wanting to know how far he is from the base. So we're finding this. We're going to call this X. So this is the adjacent to him, and we're looking for the hypotenuse. No, I'm sorry. Hypotenuse is no good to us. We have this side of our triangle. We're looking for this. So this is opposite over hypotenuse. So tangent. So tan 11 is going to equal 269, our opposite, over our adjacent, which is what we're looking for. Multiply both sides by x. X equals tan. X times tan 30 equals 269. Divide both sides by tan 11. So x equals 269 divided by tangent 11. And in calculator, it's going to be 269 divided by 11 tan equals. So again, 269 divided by 11 tan equals 1363.8. It rounds up to 1383.8 rounded up to 1384. Okay, I said I messed up the drawing here. It's actually, I said the tree is longer. He's over here. The tree is 275. We have to subtract the 6. That's why it's 269 here. Well, we're still looking for x. So hopefully that avoided any confusion or straightened out where I may have confused you. Okay, finishing up real quick. Number 14. An airplane is flying at an altitude approximately 2 miles above ground level. Pilot sights a landmark at a depression 13 degrees. A minute later, he sights the same landmark at a depression of 28 degrees to the nearest tenth of a mile. How far did the plane fly in that minute? So what we end up with, so got a plane here. And a minute later, we have the same plane. Okay. So the angle, it's going to make right angle with the ground. And our landmark, I'm just going to make it like a star or something. So the angle of depression, so one's 13. If it's 13 here, we know it's 13 down here. This one's 28. So this one's 28. We have 2 miles up, 2 miles up. Notice from our angle here, this is our opposite. And we're looking for, so from here to here, it's going to be, it's the adjacent. We're going to call this D1. We're going to call this D2. So we end up needing, where is my pencil? Where did I go? Oh well. So do these in 2 different colors. So we've got a tangent because we don't care about the hypotenuse. It's tangent is opposite over hypotenuse. So over here it's going to be tan 13 equals opposite, which is 2, over adjacent. We said D1. And then over here, this is going to be tan 28 equals opposite, which is 2, over adjacent, which is D2. Okay, so over here, we're going to multiply both sides by D1. So D1 times tan 13 equals 2. Divide both sides by tan 13. So D1 equals 2 divided by tan 13. Now over here, doing the same thing. D2 to both sides. That cancels. D2 tan 28 equals 2. Divide. Tan 28. And sorry, we're close to the table and it's getting weird here. It starts making my writing bad, or worse than normal, I should say. Okay, so D2 equals 2 divided by tan 28. So calculator, this is going to be 2 divided by 13 tan equals, this is going to be 2 divided by 28 tan equals. So 2 divided by 13 tan equals. So over here we are 8.66, which is 8.7. And then this other one is 2 divided by 28 tan equals, that's 3.76, which is 3.8. I'm hoping you can see that. So to get our answer, it's D2 minus D1. So 8.7 minus 3.8. You subtract those out and you get 4.9. So the distance that plane traveled in that minute was 4.9 miles. Let me just zoom out so you can get everything on here. I can make sure I see everything as well. Let me just scooch my paper underneath below. Okay. All right, so that finishes up the review making this video Tuesday night in case I'm not there tomorrow, Wednesday. But if I am there, you guys may be watching after the fact. Either way, if you have any questions, send me a message in Focus or ask me in class. Have a good night.